The rest of us are gonna go ahead and take a look at our equations we're solving. What did we say yesterday about these denominators? If they're all the same, I can get rid of them. And then I don't have a problem with fractions anymore. So I would love to get rid of these. But the only way I can get rid of them if they are all the same. And right now, I have a 1, an x plus 4, and an x squared plus 4x. So what is your thought on that? How might I even get this started to making them all the same? Do you notice anything about this? You can factor it. And what has kind of been our mantra all year? If you can factor it, right? Now, there will be times in your life, your math life, where it won't matter. But always do it, because I think it can be helpful. How does this factor? Take out an x, GCF, and then x plus 4. Now, this one has an x and an x plus 4. What does this one need in order to match? An x. So I'm going to give it an x. And you got to put it on the top and the bottom. Now, what does this one need? It needs an x and an x plus 4. So this one needs an x and an x plus 4, and I don't have very much room here. Does everybody see that? This denominator has an x and an x plus 4. This one needed an x in order to match, and this one needed the whole shebang because it didn't have anything to start with. Now they're all the same. So what does that mean? I don't need them anymore. So I'm going to have 2x, x plus 4, that's this, minus 3x equal to 12. Now what should I do with that? Distribute it, so that's 2x squared plus 8x minus 3x equals 12. What should I do with that? Move the 12 to the other side and go ahead and put those together. So if I do both of those at one time, I'll have 2x squared plus 5x minus 12. Okay, what do I do with that? If it factors, I'll go ahead and factor it. I'm not sure it does, but we're going to find out. I need something to multiply to 12. 3 and 4 sounds good, because look what happens when I FOIL. What do I get from my outside terms? 8. And what do I get from my inside terms? And what's 8 negative 3? 5. So there it is. Those are my factors. Am I done? No, because what am I looking for? X. So X is going to equal what? The answer to the question. This one's going to be negative 4. Does everybody agree with that? What's this one going to be?
3 over 2.
Listen, you might want to write that down to make sure you don't mess it up. It's going to be 3 over 2, isn't it? Set it equal to 0. So the other answer is 3 over 2. That's a little harder than the ones we did yesterday. All right. right, let's take a look at this one. What am I gonna do first? Factor this. How does this factor? Plus 4 minus 1. Now I will give you a little bit of a hint here. These problems are always rigged. So notice these. Those are almost always going to be these. So if you get stuck factoring, try these, because it's probably going to work. Okay, so this one has the common denominator already. It has both pieces. So, okay, what does this one need? X plus 4 on the top and the bottom. What does this one need? X minus 1 on the top and the bottom. As soon as you do that, as soon as you give this one what it needs and you give this one what it needs, now the denominators don't matter anymore. So I have 4x, x minus 1, plus 3, x plus 4, equal to 15. You guys look like it's the last period of the day. Are you with me here? You see what I'm doing? I know it's the last period. That was a math teacher's attempt at humor. Okay. Now, what do I do next? Distribute. So 4x squared minus 4x plus 3x plus 12 equals 15. So I'm gonna clean it up. So these two add together and make negative x. Can I go ahead and bring this 15 over?
Yeah.
So that's gonna be minus 3. Remember, when you got a squared in your equation, you wanna get a 0 over there. Okay? Alright, I'm gonna try to factor this. I hope it factors. I'm gonna try 4 and 1, and 3 and 1, and hope that things work out for me. That's gonna be negative 4, positive 3. Right? So what are my answers? Now, this one's easy. This one's gotta be 1. This one, you can do it in your head, but just be careful. When you're solving for x, isn't it gonna be negative 3/4? Oh my gosh. Both of these problems have an issue. Let's look at the one we just finished. Let's look at the original problem. I know I messed it all up, but let's look at the original problem. What happens if I let x be 1? It'd be 0. Where? Where is that 0 going to be in the fraction? In the top or the bottom? Okay, wait, what about that? Am I allowed to have zeros in the bottom? No. So this answer has to be thrown out. It's not that we made any mistakes, we didn't. It's what's called an extraneous root. An extraneous root, have we talked about those before? An extraneous root is an answer that you get. You haven't made any mistakes, you did everything perfectly, it just doesn't work. And 1 doesn't work because when I put it back into my problem, it makes a 0 in the bottom, and that is not Now, same thing happens over here. What happens if you put negative 4 in your original problem? What happens if you put negative 4 in? Oh boy. So that one's out. So both of these problems, instead of having 2 answers like I originally thought, are each just gonna have 1. So when do we cross out our answers? If they make our denominator 0. And that's just one of those crazy things we have to keep our eye out for. All right, let's try the next one, number 6. Okay. Does anything factor? That's how I usually start my problem. Does anything factor? Actually, I think that last denominator factors. How does that last denominator factor? What can I do? Take out an x and I'm left with x plus 1. Guys, remember what I just told you, that little hint I gave you? Always be on the lookout for that. So this is x squared plus x, but I factored it. Okay, what's my common denominator gonna be? X and x plus 1, I need both. So this one's gonna need an x. And this one's gonna need x plus 1. It's real easy, guys. Just make them match. Give them what they need so they match. And it's always multiply. You're always multiplying. When you put that x down there, it's times x. Okay, do they all match now? Yep. So this is what I have left to solve. Don't lose these signs, they're kind of buried in there. That's minus 3x. Now, I didn't worry about this one over here because if I put an x and an x plus 1, since I'm timesing up here by 0, isn't that just going to stay 0? If that had been some other number, then I would need to do it too, but 0 is special. All right, what do you think now? Foil. Okay, so here's my foiling, and then I still have my minus 3x and my plus 3. Okay, so what have I got? X squared. Okay, now I have a 1x minus a 3 minus a 3. Negative 5x. That takes care of all of those. And then I have on minus 3 plus 3. Can I factor that? Take an x out, GCF. And then set both of these equal to 0. So what does a plain x mean? X equals 0 or x equals 5. Now let's look back at our original problem. Can x be 0? Wouldn't that make it 0 there? So cross that one out. Is 5 going to be a problem? No. So one answer again, and that answer is just 5. Okay, are you keeping up here, guys? We have one more to go, and then we're ready for the next section. So here we go. So somebody besides me, tell me what to do. Factor that denominator. Okay, go ahead. I don't know if Kaylee knows what she's talking about, or if she's using my shortcut hint, but it is x plus 2x minus 1, right? That's how this factors. If you put it back together, that's what you get. So isn't that what I want in every denominator? So I'm going to start giving them what they need. This one needs the x minus 1. This one needs the x plus 2. That one doesn't need anything because it already has both of them. Now do all the denominators match? So I will forget them and just write down my numerators. Alright, now what do I do? Well, actually just distribute, yep. So 3x squared minus 3x plus 2x plus 4. Now I'm back where I was a second ago. So what have I got here? 3x squared minus 1x or minus x and minus 1. You were probably wondering when this was going to happen. Is that factor? No. Oh boy, what do I do if it doesn't factor? I use the quadratic formula. So here we go. Your job is to solve the equation. So you are not done until you can say x equals. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. One plus or minus. Now, be careful. You have a negative times a negative. So that's going to become positive. So it's 1 plus 12. So x equals 1 plus or minus the square root of 13 over 6. Now, please don't worry about those being extraneous. If you look at your problem, you can tell me what the extraneous numbers would be. The extraneous numbers would be -2 or +1. So as long as it's not that, it's okay, even though it's a radical and, ugly, it's okay. All right, 2.7, due on Monday. And we are going to begin looking at 2.8. Yeah, that's the answer right there. Now, if you want to write them separately, 1 plus root 13 over 6, 1 minus root 13, you can. You don't need to. All right, so 2.7, or 2.8, I mean, is interesting. It's in a couple of different pieces. Problems that we've kind of already done, and then some word problems, some of which we've already done. So it's kind of a repeat section in a way. So it shouldn't be too bad. We're going to get started today and finish it up next time probably. All right, so let's look at number 1. What's different about this and the other problems that we were doing? This is a less than and not an equals. So who remembers from the beginning of the year, every time we had a problem with this in it, equality symbol, what did we do every time? We drew a number line. So I'm gonna draw a number line. And I always put dots on that number line. Take a wild guess. There's 2 dots in this problem. Take a wild guess where they are.
2, negative.
Be careful.
I mean,
Negative 2 and 3. And I made them open because
There's no equal to.
there's no equal to in the problem. Right? Jose, put your head up and you go in your mouth. Okay, now who remembers what happens next? I figure out where I'm gonna shade, right? And Joseph, no, it's what you said, Joseph. Joseph said pick a number somewhere. Pick a number somewhere. So maybe here, I'll pick 4. And if I put 4 into my parentheses, I get 6 times 1. Well, 6 times 1 is 6. Is 6 less than 0? No. So what does that mean? I do not shade there. 6 didn't work. Or 4 didn't work. So I don't shade where 4 is. All right, so I'm gonna come over here. What's a number in here? 0. Let's put 0 in. 0 gives me 2 times negative 3. Now that's negative 6. Is negative 6 less than 0? Yes. So if it's a yes, that means I shade it. So I'm going to shade in here. And then I pick a number out here, like negative 3. Negative 3 plus 2 is negative 1. Negative 3 minus 3 is negative 6. They're multiplied. These are factors. They're multiplied. That gives me a positive 6. Is positive 6 less than 0? No. So the only part of my number line that's shaded is that part. So I write my answer like this. That's not an ordered pair. That's my interval notation. If these had been filled in, then I would have written it like this, right? So this is the answer to the question. Does anybody remember anything? We did these earlier in the year. Does anybody remember any kind of shortcut that we talked about? Okay, Mr. Monroe?
I think it's, I know, I shouldn't say I think. It's, like, so between -2 and 3, it's shaded, so it would just automatically, you would skip 1 and then go over to the next.
Who remembers that shading every other section thing we observed before? So if we had, let's say we had these dots. If I checked a number out here and it worked, I shaded that in, then automatically this one won't, but this one will, and this one won't. Do you remember that?
Yeah.
You should use that, kids. It works. There is only one time that it doesn't work. Does anybody happen to remember what that is? When you factor your problem, you look at your factors. If one of them has a power on it, and it doesn't matter what the power is, usually they're squares. But if one of them has a power on it, then you can't do that thing anymore. Okay? The shortcut won't work if you have a power on one of your parentheses. Okay? So just keep that in mind. Oh shoot. Oh shoot. Look at the next problem. The next problem has a power. So I'm going to go ahead and put my dots on here, -2 and 3. But to check every spot, because I don't know. These don't skip. These, sometimes you have two back to back. Okay, so I gotta check. So I'll put in -3. Now -3 gives me -1 times -6 squared. Guys, what's -6 squared?
36.
Positive 36. Times a -1 would make this -36. Is that less than 0?
Yes.
Shade it. Alright, let's try in here. Last time we tried 0, 0's fine. Any number in here is fine. So let me put in 1. I'll just put in 0. So I get 2 times -3 squared. Well, what's -3 squared? I put 0 in there. That's 9. Let's use 18. Is 18 less than 0? No. Don't shade it. Alright, let's try 4. 4 plus 2 is 6. 4 minus 3 is 1 squared. Is that going to be positive? Not less than 0, so that isn't shaded either. So for this problem, the only thing that's shaded is from -infinity to -2. Remember how we write that way? So see how it didn't skip? You have to check each one. You just have to. Oh my gosh. Well, then you check them all. Look at number 3. Number 3's got hours all over. Are the dots in the same spot? Yep. So Joshua, kind of having a hard time staying awake here. What are we gonna do? No. We're gonna pick a number. I don't care which one you pick. -3 is fine. Now, put -3 in here, guys. And just think about this for a minute. You're gonna be squaring it. So isn't this gonna come out positive?
Yeah.
Are you guys thinking?
Oh, yeah, so it's not gonna.
And is this one gonna come out positive?
So it's not gonna.
Okay, so I can go ahead and do the math. That's gonna be 1, I put in -3, so that's gonna be 1 times 36. That's not negative. If I put in 0, I get 4 times 9, that's not that's not negative. And if I put in 4, I get 36 times 1, that's not negative. What's the answer to this problem? No solution. And the reason it's no solution is because you've got something squared times something squared. Can something squared times something squared ever be negative in real number land? No, because squareds are positive. So this is positive times positive, no solution. All right, number 4, finally some new numbers. What do you think we're gonna do with problem number 4? We're gonna factor it, because that's what we do. All right, so factor it. Tyron, what you got? Got some factors for me?
X plus 4 and minus 1.
What do the rest of you think? Is he on target? Yep, perfect. So now we'll go to my number line. Put a couple of dots on there. One of them will be at -4 and one of them will be at 1. And we talked about this when we did these before. Make sure when you put your dots on there that they're in order, the right order. Am I gonna be able to use my shortcut on this problem? Yes, yes. Are either of these squared? When we talk about having a square, we mean the factors are squared. I don't mean there's a squared in the original problem, I mean the factors are squared. So I can use my shortcut here. So pick one number.
0.
0. Zero's in here. So 0 would give me 4 times negative 1. Is that greater than 0? No. Which means this is not shaded, which means this and this are. So you remember how to write that? Negative infinity, negative 4, union, 1, infinity. Try number 5, you and your partner. So each of you do it, and then compare your answer. You're going to be doing exactly what we just did. The steps are the same. You and your partner, see what you can figure out.
0.
I promise that all the problems I give you like this will be factorable. Okay, because I'm expecting you to put them on a number line. So you should be able to factor these. Did you put dots on your number line at 3 and 4?
Yeah.
And did you color in the dots?
Yes. But now I know.
Titus, what would be a good number to pick? It doesn't matter, pick one. What would you want to pick? 5. So 5 is out here. So he's checking to see if he's gonna shade out here. So 5 minus 4 is 1. 5 minus 3 is 2. Should he shade out here?
Yes.
Yeah, because 2 is bigger than 0. So if he shades there, he's also gonna shade here.
Yes.
4 equal to doesn't matter, except when I write my answer, I have to use a bracket. Never on the infinity, but on the numbers. All right, so I'll tell you what, we're gonna do one more problem, all right? Hang in. We'll do one more. You can do this. Okay? You can. All right, let's look at number 6. Oh boy. Be careful. Can this one factor by grouping?
No.
Do you have to synthetically divide?
I don't know.
Oh, man. If it doesn't factor by grouping, I have to look at my PRRs and guess and divide. That's what I do, right? We know how to do that. So what are my PRRs? Factors of 6. So you wanna try 1? Haley says I wanna try, over factors in the
Sorry.
But you wanna go ahead and try 1? I think 1 looks good, actually. Let's try 1. Woo, we got 1. What do we do now?
Or the 1 negative 1 and negative 6 is.
X squared minus x minus 6. And that should factor, I'm promising you it will. So that's gonna be, for these problems, these inequalities. Minus 3 example, how many dots are on my number line?
2.
No,
Oh, wait.
3 dots. First of all, kids, see this right here?
Oh, no.
That's a clue. So here are 2 of them. 1 dot will be at 3 and 1 dot will be at -2.
The other one's at 1.
And the other one's at 1. This is a dot, just like it was in the last part of the chapter. So on my number line, I'm going to have 3 dots. They're all closed. And they're at -2, 1, and 3. Make sure you got them in order. Is that okay? Now, if the dot is at 1, wouldn't the factor be x minus 1? You don't have to write that down, but I want you to see that none of these have powers on them, which means that I'm going to check one section and then use my shortcut. Okay, so one number, what do you want to try?
0.
0. If you try 0, 0's fine, I love 0, 0's great. But this is where it is, so this is the interval that you are checking on. So putting 0 in, and you can put it in the original, or you can put it in your factors. It doesn't matter, you can put your number in wherever you want. If you put it into your factors though, make sure you're putting it in all 3. Gotta go in all 3. So 0 would give me -3 times 2 times 1. What's -3 times 2 times 1? -6. Is -6 less than 0? Oh, it's -1, yeah, I was gonna say, that doesn't make sense, yeah. So it's -1, thank you, which is +6. +6 is not less than 0, so this does not get shaded. So this one does, this one does, and that one doesn't. So my answer, -infinity to -2 bracket, union 1, 3 bracket. Is that okay? All right, I promise I'd stop there, so I shall. You can go ahead and pack up, and I need you to sit quietly for prayer. Again. I think one of you guys know this dismissal, aren't you?
He's already gone.
No, there's another one out here that's got another dismissal.
Wait, which one?